Hello, this is my extra credit point for Module 10, Chapter 19, and number 5. So I'll start out by reading the question, and it's referring to customer ages. So an analysis at a local bank wonders if the age distribution of customers coming for service at his branch in town is the same as at the branch located near the mall. So he selects 100 transactions at random from each branch and researches the age information for the associated customer, and then here are the data below. So the first question is asking what is the null hypothesis? And I'll kind of go back and forth between these questions and then my Word document that I made. So the null hypothesis is that the age distributions of customers at the two branches are the same. And then the next question asks, what type of test is this? And I said it's a chi-square test of homogeneity. And that's because we are selecting two random samples from each subgroup separately and then collecting data on a single variable. And the variable we will be looking at is age. And then what are the expected numbers for each cell if the null hypothesis is true? So I began by taking the total, so 50 divided by the total of less than 30, and then the total of 30 to 55, and then 56 or older, divided by the 200. So 50 divided by 200 gave me 0.25, and then 90 divided by 200 gave me 0.45, and then 60 divided by 200 equals 0.30. So the way I got each cell was taking the number that we got and multiplying that by the total from the in-town branch and then the mall branch. So, for example, I took 0.25 from the first column and multiplied that by 100 and got 25. And then keep in mind that these will be the same because the total is both 100 for these. And then for the next one, I got 0.45 times 100 is equal to 45. So that's the expected frequency for this. And then 0.30 times 100 equals 30. So that's the expected frequency for 56 or older. And then for the difference, so since we got 25 for less than 30, we can do 20 minus 30, or 20 minus 25 is -5, and then 30 minus 25 is 5. And then for 30 to 55, 40 minus 45 is -5, and then 45 minus 50 is -5 as well. Let's see that, yeah. Or 5 is just 5. And then 40 minus 30 is 10, and then 20 minus 30 is -10. So from there we can get our x squared statistic by taking the observed minus the expected and then squaring that. And then after you do that for each cell, you would add them up. And I got the total of 9.78 as the x squared statistic. And then for the degrees of freedom, you just take the two rows, so 2 minus 1, and then multiply that by the columns, so 3 minus 1, and that gave me 2. And then the p-value was very small. I got less than 0.01, but here's the exact number, 0.0075. I just got that by looking on the graph. This is like the exact number, but if you looked at the graph, it would just be 0.01 or less than that. And then for my conclusion, I decided to reject the null hypothesis since the p-value is small, and I concluded that the age distribution at the two branches are not the same. And then some suggestions if you need more help on ways to do this or go about this problem. I suggest you watch the Module 10 video of homogeneity, or you can also view the example of a chi-square of homogeneity test on page 620 of our book. That's it. Thanks.